An open neutral in a three-wire electrical system can trigger a cascade of problems leading to unexpectedly high energy bills. The core issue stems from voltage imbalance. Ordinarily, in a balanced system, the voltage is evenly distributed between the phases. However, when the neutral connection is compromised, it creates an unbalanced load, causing one phase to experience a higher voltage while the other experiences a lower voltage. This voltage imbalance can have several negative consequences. Firstly, increased power consumption. Electrical devices and appliances are designed to operate within a specific voltage range. When the voltage supply is unbalanced, these devices may draw more power than necessary to compensate for the voltage drop on one phase. Motors, for example, may work harder to maintain their speed, consuming more energy in the process. This increased energy consumption directly translates to higher electricity bills. Secondly, equipment failures. Voltage imbalances can put undue stress on electrical components, leading to premature failure of appliances, motors, and lighting fixtures. Over time, this can result in costly repairs and replacements. Furthermore, failing equipment often operates less efficiently, further contributing to increased energy consumption. Thirdly, neutral current and harmonics. A properly functioning neutral wire provides a return path for current, ensuring that it flows evenly back to the source. When the neutral is open, current may find alternate paths flowing through the line 1 and line 2 conductors. This neutral current can introduce harmonics into the system. Harmonics are distortions in the waveform of the alternating current, which can cause equipment malfunctions, overheating, and increased energy losses. In some cases, the utility company's metering equipment may not accurately measure energy consumption when an open neutral is present. The voltage imbalances and neutral current can interfere with the meter's readings, potentially leading to overbilling. When the utility company replaced the service line and transformer, they effectively resolved the open neutral issue. This action restored a balanced voltage supply to the customer's house, addressing the root cause of the problem. With the voltage imbalance corrected, devices and appliances no longer had to draw excessive power to compensate for voltage drop. Motors operated at their designed efficiency, and appliances consumed only the energy they needed. This resulted in a significant reduction in energy consumption, leading to lower electricity bills. Furthermore, the balanced voltage supply eliminated the premature equipment failures caused by voltage imbalances. Appliances and motors lasted longer, reducing the need for repairs and maintenance. Finally, resolving the open neutral issue ensured that the utility company's meters could accurately measure the customer's energy consumption. This eliminated any potential billing errors, ensuring that the customer was only charged for the electricity they actually used. The significant reduction in the customer's electricity bills after the open neutral issue was resolved can be attributed to a combination of factors including reduced power consumption, fewer equipment failures, and accurate billing. The correction of the voltage imbalance had a ripple effect throughout the electrical system, improving efficiency, extending equipment lifespan, and ensuring fair billing practices. It's important to note that an open neutral is a serious electrical hazard that can pose a risk of fire, electric shock, and damage to equipment. If you suspect that you have an open neutral in your electrical system, it's crucial to contact a qualified electrician immediately to diagnose and repair the problem. Ignoring an open neutral can lead to further damage, increased energy costs, and potential safety risks. An open neutral in a three-wire electrical system creates voltage imbalances leading to increased power consumption, premature equipment failure, and potential billing errors. Addressing and resolving the open neutral ensures efficient operation, extended equipment lifespan, and accurate billing. Early detection and professional repair are essential to avoid hazardous consequences. Let's look at a practical example. Imagine a home with several appliances including a refrigerator, air conditioner, and various lights and electronic devices. Before the open neutral was fixed, the voltage on line 1 might have been significantly lower than the voltage on line 2, perhaps 108 volts on line 1 versus 132 volts on line 2 when it should be approximately 120 volts on each line. As a result, the refrigerator motor might have worked harder to maintain its cooling temperature, consuming more electricity. The air conditioner might have run less efficiently, leading to higher energy usage, and lights might have flickered or burned out prematurely. After the utility company corrected the open neutral, the voltage on both line 1 and line 2 was restored to a balanced 120 volts. The refrigerator motor operated at its designed efficiency, consuming less electricity. The air conditioner ran more effectively, leading to lower energy consumption, and lights burned steadily and lasted longer. In addition, the homeowner no longer had to worry about premature appliance failures or inaccurate meter readings. This demonstrates how correcting an open neutral can have a significant impact on energy consumption, equipment lifespan, and overall electrical system performance. Furthermore, consider the impact on sensitive electronic equipment such as computers, televisions, and audio systems. Voltage fluctuations caused by an open neutral can damage these devices, leading to data loss, distorted images and audio, or even complete equipment failure. Replacing these devices can be costly, and the inconvenience of dealing with repairs or replacements can be significant. By addressing the open neutral promptly, homeowners can protect their investments in electronic equipment and avoid these costly disruptions. From an electrical safety perspective, an open neutral can create hazardous conditions. When the neutral connection is compromised, the grounding system may become energized, potentially exposing individuals to electric shock. Appliances with metal housings that are normally grounded could become energized, presenting a risk of electrocution if someone touches them. In addition, an open neutral can increase the risk of electrical fires. Overheated wires and connections can ignite nearby combustible materials, leading to a fire. Therefore, it's essential to address an open neutral as soon as it's detected to prevent potential safety hazards. It's also important to consider the impact of an open neutral on the overall electrical grid. If multiple homes in a neighborhood have open neutrals, it can create instability in the grid, potentially affecting other customers. The utility company has a responsibility to maintain a stable and reliable electrical supply, and addressing open neutrals is a crucial part of that responsibility. Routine inspections and maintenance of the electrical grid can help identify and correct open neutrals before they cause widespread problems. In addition, customers should report any suspected electrical issues to the utility company so that they can be investigated promptly. In conclusion, an open neutral in a 3-wire electrical system can have far-reaching consequences affecting energy consumption, equipment lifespan, electrical safety, and the overall stability of the electrical grid. Addressing and resolving open neutrals is essential for ensuring efficient, reliable, and safe electrical service. Prompt detection, professional repair, and proactive maintenance are crucial for preventing potential problems and protecting homes, businesses, and communities. From a technical perspective, the open neutral affects the impedance of the return path for current flow. Normally, the neutral wire provides a low impedance path, allowing current to flow easily back to the source. When the neutral is open, the impedance of the return path increases, causing voltage drops and imbalances. The severity of the voltage imbalance depends on the load distribution on each phase. If the loads are balanced, the voltage imbalance will be minimal. However, if the loads are significantly unbalanced, the voltage imbalance can be substantial. To diagnose an open neutral, electricians use specialized testing equipment such as voltmeters and impedance testers. These tools allow them to measure voltage levels and impedance values at various points in the electrical system. By comparing these measurements to expected values, they can identify the location of the open neutral. Once the open neutral has been located, it can be repaired by restoring the continuity of the neutral wire. This may involve tightening loose connections, replacing damaged wiring, or installing a new neutral wire. It's important to ensure that all connections are properly tightened and insulated to prevent future problems. In some cases, an open neutral may be caused by a problem with the utility company's equipment. In these situations, it's necessary to contact the utility company to have them investigate and repair the problem. The utility company may need to replace the service line, transformer, or other equipment to resolve the issue. It's also important to consider the role of grounding in electrical safety. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. An open neutral can compromise the effectiveness of the grounding system, increasing the risk of electrical shock. Therefore, it is essential to ensure that the grounding system is properly installed and maintained to provide adequate protection. Regular inspections and testing of the grounding system can help identify and correct any potential problems. In addition, homeowners should be aware of the signs of a potential electrical problem such as flickering lights, unusual noises or smells, or tripping circuit breakers. If any of these signs are present, it's important to contact a qualified electrician to investigate the problem. Ignoring these signs can lead to more serious problems, including electrical fires. In conclusion, an open neutral in a 3-wire electrical system is a serious problem that can have far-reaching consequences. Addressing and resolving open neutrals is essential for ensuring efficient, reliable, and safe electrical service. Prompt detection, professional repair, and proactive maintenance are crucial for preventing potential problems and protecting homes, businesses, and communities. An open neutral not only affects individual households but also impacts the overall electrical distribution system. When numerous open neutrals exist in a local area, they can create a ripple effect of voltage instability. This instability can lead to voltage fluctuations across the grid, which can negatively impact sensitive electronic equipment and industrial machinery connected to the network. Utility companies take great care in monitoring and maintaining the balance and stability of the power grid. Regular inspections and maintenance programs are implemented to identify and rectify potential issues like open neutrals before they escalate and affect a broader customer base. These programs often involve infrared scanning to detect hotspots in electrical connections, which can indicate loose or corroded terminals that may lead to open neutrals. Furthermore, advanced metering infrastructure, or OMI, provides utilities with real-time data on voltage and current levels throughout the distribution network. This data can be analyzed to detect imbalances and anomalies that might point to an open neutral condition. AMI systems enable proactive responses, allowing utilities to dispatch crews to investigate and resolve potential problems before they cause widespread disruptions. The economic impact of open neutrals extends beyond individual customer bills. Industries and commercial enterprises that rely on stable and consistent power supplies can suffer significant losses due to voltage fluctuations and equipment failures caused by open neutrals. Manufacturing plants, data centers, and hospitals, for example, are highly sensitive to power quality issues. Interruptions or voltage variations can disrupt operations, damage equipment, and lead to costly downtime. In such cases, businesses may incur expenses related to repairs, replacements, and lost productivity. Moreover, the cumulative effect of numerous open neutrals can place strain on the electrical grid infrastructure. Utility companies may need to invest in additional equipment, such as voltage regulators and capacitor banks, to compensate for the imbalances caused by open neutrals. These investments can increase operating costs, which may eventually be passed on to consumers in the form of higher electricity rates. From a regulatory perspective, electrical codes and standards play a crucial role in preventing and mitigating the effects of open neutrals. The National Electrical Code, or NEC, provides guidelines for proper wiring practices, grounding techniques, and equipment installation. Adherence to these codes helps ensure that electrical systems are designed and installed in a safe and reliable manner, minimizing the risk of open neutrals and other electrical hazards. Local jurisdictions typically enforce the NEC and other applicable standards through inspections and permitting processes. Electrical contractors are required to obtain permits for electrical work and undergo inspections to verify compliance with codes. These measures help prevent substandard installations that could lead to open neutrals and other problems. In addition, ongoing education and training for electricians and electrical inspectors are essential for maintaining a high level of expertise and ensuring that they are up to date on the latest codes and best practices. In summary, open neutrals in 3-wire electrical systems pose a multifaceted challenge that affects individuals, businesses, utility companies, and the overall electrical grid. Addressing open neutrals requires a collaborative approach involving homeowners, electricians, utility providers, regulatory agencies, and industry organizations. By working together, these stakeholders can promote safe, reliable, and efficient electrical service for all. The resolution of open neutrals is not merely a technical fix but a commitment to the health and safety of our communities.